Lesson 12, Filters. Section 12.1. Low-pass filter using an RC circuit. Experiment 12.1. Pause the video, and follow the instructions. This is to test a low-pass filter by measuring its frequency responses. These are the measured frequency responses. The top graph shows the voltage gain GV. The bottom graph shows the phase difference psi V2 to V1. If the frequency of V1 is 0.1 kHz, the voltage gain GV equals negative 0.04 decibels. The absolute value of V2 equals 0.995 times the absolute value of V1. The input voltage V1 passes through the circuit. If F equals 10 kHz, GV equals negative 16 decibels. The absolute value of V2 equals 0.16 times the absolute value of V1. V1 is attenuated by this circuit. At F equals 1.53 kHz, the gain drops by 3 decibels from the highest gain, and V2 lags V1 by 45 degrees. This 3 dB down point is defined as the boundary between the pass band and the stop band. Components in the pass band pass through this circuit, and those in the stop band are stopped or filtered out by this circuit. Thus, this circuit is called a low-pass filter. This frequency is called the cut-off frequency, denoted by Fc. The voltages and currents are represented by complex numbers. V2 is given by this equation. Thus the voltage gain GV and the phase difference psi V2 to V1 are derived as shown in these equations. If omega CR equals 1, then GV equals negative 3 decibels, and psi V2 to V1 equals negative 45 degrees. From omega CR equals 1, the cut-off frequency Fc is given by this equation. In this RC circuit, Fc is calculated to be 1.59 kHz. The result in experiment 12.1 was almost equal to this theoretical value. Let's approximate this equation. If F is much smaller than Fc, then J omega CR is much smaller than 1. Thus, this term is negligible. Then V2 is almost equal to V1. GV equals 0 decibel, and psi V2 to V1 equals 0 degree. If F is much higher than Fc, then the term 1 is negligible. The approximated GV and psi V2 to V1 are obtained. The red lines in these graphs are approximated lines. The blue lines represent the characteristics measured in experiment 12.1. The author of this material is Takeshi FURUHASHI, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.